Alright, welcome back, folks. Okay, we're looking at 2.4, complex numbers. Okay, we're going to be performing operations on complex numbers and solving equations with complex solutions. Okay, the basics of this whole thing, again, this is a big Algebra 2 review, so hopefully this makes a lot of sense. Alright, I is, basically the definition, is the square root of -1. And the implication here is if you think about squaring both sides of this equation, well, you get I squared on the left, and then the root and the square cancel each other on the right, so you get I is -1, or at least I squared is -1. Alright, so moving on from that, the standard form of a complex number, okay, that's the a plus bi. You've probably seen that before. If not, that's standard form. A and b are going to be real numbers, so basically you don't have other i's mixed in with that I when you've got a final answer, is basically what that says. Okay, and then the book's going to use a little bit of terminology, and I don't want you to freak out when you see it, so here we go. If b is equal to 0, so if the b part here is 0, that basically kills off the I as well, and then just leaves you with an A, and again, that's a real number, so basically that makes the whole thing a real number. And a real number, of course, is any number you've ever seen that doesn't have an I attached to it, so something like 13 or 17 or even like 2 root 7. Could be anything you want it to be, so I'll just, as an example, put down the number 3. Alright, and if b is not equal to 0, so that means we do have an I involved. There's no restriction on a here, so you may or may not include it, but basically what you have here is an imaginary number. And for example, you might have something like -8 plus 6i in that case. Alright, so you have both kind of the real and imaginary part, although the real part is not necessarily there based on this definition, but there you go. I purposely put the a part in because this one specifically says that it's not there. And so if I've got a is gone but b is there, that's basically what that says, then what you have and what the book's going to refer to this as a pure imaginary number. And I think they mean pure because, again, if you don't have this real number part and you just have the imaginary part to it, you have something like -5i. So the one term that you have has an I in it, so therefore it's purely imaginary. But anyway, that's just some terminology the book's going to use, so don't freak out when you see it. Alright, one thing that doesn't come up a ton, but on occasion it does, so it's important to mention, saying the two complex numbers are equal. Alright, so if I've got two complex numbers, a plus bi and then c plus di, if those two guys are equal, as indicated by the equal sign, very, very subtle, I know, alright, well, that implies actually two different equations here. Okay, basically what that implies is that the real part equals the real part, and the imaginary part equals the imaginary part. So again, two little equals come out of that, so, and whatever. Alright, so if you're given something like this and asked to solve for x and y or whatever like that, okay, all you have to do again is put the real part with the real part. So I've got the 6 is the real part here and the y is the real part there. So 6 equals y, earth-shattering realization right there, but really nothing to do there. Okay, and then as a second one, I've got this x plus 5 with the I attached to it is equal to the -9i. So again, not overly challenging here, but still x plus 5 equals -9, so then x is going to equal -14. Okay, so just kind of a fancy way to almost hide a system or something like that, but don't get too wrapped up in it. It's not that deep of an issue, but there it is, now you've seen it. Okay, now I'm not going to do too many of these, but for simplifying, adding, subtracting, multiplying these things, here it is. This is a simplification. We've got a negative inside the radical sign, and so normally that makes people freak out, or in Algebra 1 you just say no solution or can't do it or something like that. Alright, but basically what this means is that I've really got the square root of -1 times the square root of 45. Of course, the square root of -1 turns into an I. Okay, safety tip, when you're writing your I's, make sure you do something to indicate a little bit of difference between a 1, because if you forget the dot or your dot is light, sometimes it'll look like a 1 depending on your handwriting, so I like to put the little hook at the bottom. Alright, moving on from there, I'll put my time sign in, and then of course root 45 works out to be a 3 root 5. Feel free to check me on that, but there it is. Okay, and then this looks a little bit awkward, so basically I think it's a little bit nicer. Treat I sort of like a variable. Think of it as 3i root 5. Okay, now that's what I like. You can see up here in the corner I've got the book versus Mr. Rowe's answer format. Okay, what the book is going to do in this case, and I think it's kind of sloppy form, but it's what the book does anyway. The book gives us an answer of 3 root 5i. And I don't like that because, if you're a little bit sloppy with your radical symbol, it's very easy to have 3 root 5 with the I right there, and it looks like the I is underneath. And it is possible to take the square root of I, but we're definitely not trying to do that. So I like to put it in front like this because I think it's just a little clearer that you're not trying to take the square root of it. Just a little nicer communication to whoever's looking at your work. Me. Alright, this next example is actually a problem that I wager you'd probably get right even without any sort of instruction, so I'll just kind of buzz through this really quickly. Okay, we got 15 minus 2i. There was nothing in front to distribute, so it stays what it is. Distributing a negative 3 here gives me a negative 3, then plus 15i. And then it's just a matter of like terms. 15 and the minus 3 gives us a 12, and then the negative 2i with the positive 15i gives me a positive 13i. And really, that's all you can do, so again, pretty simple. Alright, now this sort of FOIL situation does cause some problems on occasion, so here it is in all its glory. Okay, again, it looks like FOIL because it is. Alright, so as we multiply the 7 times the 6, we get a 42, of course. 7 times the minus I gives us a minus 7i. 4 times 6 with an I on it gives us a 24i. And then finally the 4i times minus I gives me a minus 4i squared. Okay, now if this was FOIL, you wouldn't do much more than combine the first two guys, or sorry, the middle two guys. However, because I squared, remember from the very first slide of this thing, I squared is equal to negative 1, so it actually has another implication for us that this is actually, and I wouldn't expect you to write this step normally, but just for demonstration purposes, got this, and this negative 1 gets together with that negative sign actually makes us a plus 4 right there. Okay, so really what I would expect you to write at this point is the 42 and the 4 make a 46, and then these guys over here combine to be a positive 17i. So just watch out, anytime you end up with an exponent, basically, make sure you turn that I into a negative 1, or at least when you end up with a square. We'll cover something a little more drastic later, but there it is for now. Alright, now the term conjugates I am going to use semi-frequently. Here it is. Conjugates we're going to find and multiply. So we're going to find the conjugate first of all. Now the conjugate of any term like this is simply the same two terms with the different sign in the middle. So first of all, if I've got that guy, its conjugate is going to be, again, same exact two terms, but change the sign in the middle. So 9 plus 2i is this guy's conjugate. We're going to multiply them. So take 9 minus 2i, and then 9 plus 2i, and again, it's a FOIL. Okay, if you're slick, there is something you can notice real quick here. Okay, that is an equal sign. Alright, so multiplying out, I get an 81, and then I get a positive 18i, and then I get a minus 18i. Interesting. Then I get a minus 4i squared. Okay, so there's two things interesting about what's happening. Of course, just like the last problem, that negative 1 is something we can get from the I squared. But then these two guys here, the positive 18i and negative 18i, will just cancel each other out. So again, a step that you probably won't do on your own is I have now 81, and this is a plus 4, so this works out to be 85. Okay, I made up my own word for this. Okay, anytime I'm going to FOIL conjugates, okay, the special nature of conjugates, the O part and the I part of FOIL, if you want to think of all the various letters of FOIL, okay, the O and the I are going to cancel each other out every time if you actually are multiplying conjugates. Now, it's got to be conjugates for that to work, but anytime I see that, the word I made up is conjufoil. Okay, I'm foiling conjugates, so basically you can just cheat and just do the F and the L part because the other two are going to cancel anyway. So there's my 81, and then if I do this, negative 4i squared, the I squared becomes a negative, making it a plus 4, and so basically I can skip from this step to this step if I have conjugates. And there it is, conjufoil. Woohoo! Fun words with Mr. Osborne. Alright, now when we're dividing complex numbers, in this case I've got a real and then a pure imaginary, so as we're dividing these guys, basically normally you would think there's nothing wrong with this, but again, think of the basic what I equals. Since I is a square root of negative 1, basically what we have here is we have a situation with a radical in the denominator, and we're not allowed to have that sort of thing, so we basically are rationalizing here. Okay, and really there's nothing wrong with the 5 in the denominator, so the only thing you need to fix is the root part. And so all I have to do is multiply by I top and bottom here. Okay, so this gives me negative 7i and then 5i squared. Okay, now as I've done a couple times now, that I squared is going to become a negative 1. So this is negative 7i over negative 1 times 5 is a negative 5. And then of course at this point those two negatives would cancel, and that gives me simply 7i over 5. Alright, so that's how I'm okay writing it, although the book is going to go a little bit differently. Although I don't think the book versus myself is either right or wrong here, but what the book is going to do is write that as 7/5 and then kind of put the I off to the side. Either one of those I don't think is bad, so go with whatever you think looks better to you. Okay, now here's another division that's a little messier because we've got multiple terms in the denominator, so I can't simply multiply by I top and bottom to clean up all the i's. If you don't believe me, feel free to do it and see the mess that ensues, and if you're not sure about it, come see me tomorrow in class. But anyway, okay, the reason that we talked about conjugates earlier, because that's what you need to use here. Okay, remember when we multiplied conjugates, the I parts disappeared. So whatever the denominator is, if it's a two-term expression, multiply it by its conjugate, but of course do these top and bottom. Okay, so at this point, okay, I can FOIL my denominator, or again, conjufoil. So here I'm just going to cheat and go to the 25. Okay, and then again I'm going to get a negative 4i squared, which is going to turn into a positive 4. So go a little bit quicker that way. Okay, and at this point, now the 6i distributes into the 5, giving me a 30i. And then the 6 into the negative 2i gives me a negative 12i squared. Okay, granted, if you went straight to a plus 12 there, that's probably a good idea, but whatever, here we go. Okay, like I said, that's now a positive 12. And then from there, I've got this 30i that's just kind of hanging around, having a good time. And then on the bottom, 25 and 4, well, that's 29 as far as I'm concerned. And again, I'm okay with that as an answer. The book is going to stress the standard form sort of thing, so the book, and again, I don't know if one of these is better than the other. But the book is going to split that fraction up into two separate fractions. So it's going to give you 12 29ths plus 30 over 29i. So again, I don't think one is better than the other necessarily. I'm lazy, so I like writing the 29 just once instead of twice like the book is going to do. Alrighty, if you run into a situation like what you see here, and you have to add or subtract fractions, and you have imaginary parts in the denominators, okay, you're going to have kind of a messy situation, and there's about two ways you can handle it. First, we can rationalize the fractions separately and then add the results, or we can add them first, ignoring the fact that you have i's in the bottom, but then rationalize whatever denominator you get when you're done. Just for picking one and run with it, I'm going to pick the rationalize then add option. The other one is good as well. I don't think one's necessarily better than the other, but I'm just going to take it and run. And if you want to work it out the other way, please feel free. You should get the same answer. It should just take you a different set of steps to get there. So anyway, I'm going to go with the rationalizing first thing. So I'm using the conjugate, and I'm going to do that both on the left fraction and on the right fraction. So 2 minus I over here. Another thing I'm going to do real quick is change this to a plus negative 1. That'll help me not make some sign mistakes in a few minutes here, or a few seconds rather. Okay, so now I'm going to distribute my numerators. So on the left, I'm going to have a 6 minus 3i. Okay, and again, I'm conjufoiling here, so I can cheat a little bit. Okay, I'm going to get 2 times 2 is 4, and then negative I times positive I gives me a negative I squared, and again, that I squared and the negative sign actually make a plus, so this actually works out to be 4 plus 1. Alright, likewise, now I've got a plus sign there. Distributing here gives me a negative 4 minus 3i. Alright, and then on the bottom, same basic thing, I've got conjufoil, so I get a 16 minus 9i squared, which actually turns into 16 plus 9. So I'm going to have a 5 here and a 25 there. Okay, so cleaning up what I have, 6 minus 3i over 5 plus negative 4 minus 3i all over 25. Okay, now this one worked out kind of fortunately in that getting a common denominator is not too tough. All I have to do is multiply the left guy by 5 top and bottom, and I'm in business. Alright, so just taking care of that, I've got 30 minus 15i all over 25, and then plus, well, the guy that's already sitting there. Okay, now for space issues, I'm going to go horizontally, so please don't freak out. Alright, now combining like terms across the top, I've got a 26, and then I've got a minus 18i. And again, that's all over 25. Okay, and again, as far as I'm concerned, that's good. And again, the book, because it's going to stress the whole standard form a plus bi thing in the directions of its problem sets mostly, it's going to go with 26 25ths, and then minus 18 over 25i. Okay, again, on a quiz, I'll accept either one. So go with whichever of those looks better to you. Alright, if you're multiplying radicals like you see here with this example, initially you might just think, hey, multiply those together and the negatives cancel out, which, okay, that makes sense. Unfortunately, the rules that you're using there is based on a set of rules that only work for real numbers. We have imaginary numbers here, so we can't use those rules. Fortunately, there's a movie that has a little scene that explains how to do this problem. I'm going to play this for you now. The kid says something that's a little bit hard to follow, but what Santa says, Santa's the one who's actually got the answer. So especially pay attention to what Santa has to say here.
No, I want an official red undercover knife shoot you in a jet monumental rifle.
You'll shoot your eye out, kid. Merry Christmas. Ho, ho, ho.
Okay, now from what Santa said, well, you're going to shoot your eye out, kid. And that's exactly what you guys need to do as you're doing this. The real number system doesn't apply, so all you need to do is take these and shoot them out. So shoot your eye out, kid, because those negative signs exactly become eyes. So who knew Santa was so smart, huh? Okay, so this becomes I root 18 times I root 15. Okay, and at this point, well, now we have some real numbers. Granted, there's some imaginary stuff, but we can kind of keep them separate. So we have I squared, and then root whatever the heck 18 times 15 is. I'm going to blow your minds right now and say I don't care. I just know it's some big number. Okay, because keep in mind, the very first thing I'm going to do is break this guy up. So I'm going to tree it out, and hey, what two numbers might multiply to be that big number? Well, it's 18 and 15. Again, I don't care what that number was. Alright, so from there you just continue with your tree, and okay, whatever you got. I got 2 and 9. This works out to be 3 and 5. And then a pair of 3s right there. Okay, so I can have a 3 come out, and then I have a 2, 3, and 5 all left over, so that gives me a 30, and this I squared becomes a negative 1. So basically I have negative 1 right there. Okay, the 3 comes out, and then the root sign with stuff left over is a 30. So cleaning this up, again, pardon me for going horizontally, gives me negative 3 root 30. Okay, and again, you might think, well, I got almost the same thing, but unfortunately, losing that negative sign right there is kind of a big deal. So make sure you pay attention to that, and do as Santa says, make sure you shoot your eye out, kid. Okay, now solving equations here is basically intended to go, hey, there's an I that's going to show up. Hopefully you'll look at that one and think, hey, maybe I can try factoring it, but after a little bit you go, ooh, I can't factor it, let's use the quadratic formula. So x equals negative 8 plus or minus the square root of 8 squared minus 4 times 3 times 10 all over 2 times 3. Okay, and then just cleaning this mess up here, you can have a negative 8 plus or minus. Okay, now 8 squared is 64, 4 times 3 is 12, times 10 is 120. So basically my discriminant is 64 minus 120, which works out to be a negative 56. Alright, and that's over 6. Okay, the square root of 56. Okay, again, technically negative 56, so I am going to have an I coming out. And then the 56 works out to be 8 and 7, and then of course 2 and 4, 2 and 2. So I've got a pair of 2's, then I've got a 14 left over with an I along for the ride. So what happens here is you get negative 8 plus or minus 2I root 14 all over 6. And this guy is nicely reducible by 2. So this gives us negative 4 plus or minus I root 14 all over 3. Okay, again, I'm happy with that. The book is going to break that up into 2 separate fractions. But again, negative 4 thirds plus or minus root 14 thirds I is what the book will give us. But again, I'm much happier personally with the one on the left, but equally correct is the right one. Alright, now powers of I. This is something I really like because I do. Alright, so without wasting too much time here, I to the first, well, anything to the first is just itself. Okay, and from before we know that I squared is actually negative 1. Alright, so the I to the third, you might think, well, I to the third. Well, if I have I to the third, that's the same thing as having I squared times I to the first. Okay, and well, I squared is negative 1, and I to the first is I, so negative 1 times I is actually negative I. That's kind of cool. See, I to the fourth, well, I could think of that if I wanted to as I squared times I squared. Well, I squared is equal to negative 1, so this is really negative 1 times negative 1, which is positive 1. Hey, that's cool too. Alright, and by no accident I put the I to the fifth up here. Because I to the fifth, I can think of that as I to the fourth times I to the first. Well, I to the fourth is 1. It's convenient. And then I to the first is just I, so this is really 1 times I, which again is just I. I to the sixth, I to the fourth times I squared. Alright, and of course I to the fourth is still 1. I squared is negative 1, so 1 times negative 1 is negative 1. Hopefully you're noticing something here. I to the fourth times I to the third is how I could break up I to the seventh. I'm using the I to the fourth on purpose because it's a 1. So 1 times I to the third is whatever I to the third is, which is negative I. Okay, notice the pattern. I to the fourth times I to the fourth, okay, is 1 times 1, so that's again a nice pretty 1. Okay, hopefully, without much convincing, I can convince you here that this is an I, negative 1, negative I, and then positive 1. Okay, and we can cycle through that all day if we want to, but for powers of I, notice that every single time any power works out to be one of these 4 numbers. And as a good rule to go with, at least I think it's a really great rule, there's other ways of doing this, so if you know another one, feel free to use it, but basically my rule that I like to go by is I to any multiple of 4 power is equal to 1. Okay, and that basically allows you to take any power of I and then boil it down to, again, one of those 4 numbers fairly quickly. Okay, now let's put that rule to the test a couple times. Okay, if I've got I to the 26th, well, what I want to do is break that into I to some multiple of 4, which is as close to 26 I can get without going over, times I to whatever the leftovers are, basically. Alright, so I to the 26th, well, the power of 4, or at least the multiple of 4, sorry, below that is 24. Alright, because that's a multiple of 4. And then the leftovers for that are I squared. Okay, now again, I don't have to work that out, because since it's a multiple of 4, I know it's equal to 1. And then the I squared, well, I squared, hopefully that's one you can have memorized, that's negative 1, so I to the 26 is actually equal to 1 times negative 1, or just simply negative 1. Okay, again, boils down to something very, very nicely, very, very quickly. Same thing over here, I to the 75th, well, I need to again think about multiples of 4. And so let's see, a multiple of 4 below 75 is 72. And then from there, I can just go I, again, the leftovers is I to the third. Okay, again, that first guy becomes a 1. And then the I to the third, again, hopefully you can keep that straight. That's negative I. And so 1 times negative I is simply negative I. So again, boils down to something very, very simple, very, very quickly, as long as you can kind of figure out some multiples of 4 to work with. Alright, now here's our assignment. Okay, 63, I'm just having you skip that one because the answer is just completely messy and I would never do that to you. Make sure you do the hardest 2 or 3 per section. If you need more help than that, of course, do more problems. There's the answers to the couple of evens, and yeah, you can read that. Good luck. See you in class.